Hello, this is Dr. Kraus, and I wanted to take a few minutes to do just a supplemental lecture on units. I've sort of glossed over that a little bit until now, and I've depended on Google for all my unit conversions, and obviously you're not going to have Google during the exam. So I want to give you an example of what I did or what I learned when I was in high school back before some of you were born, especially for compound units. So what if I had a spring constant where K was 5 pounds per inch. And pounds are funny. I'm going to specifically say lbf for pounds force, pounds mass. Sometimes that's a little weird. But I've got a compound unit, and I've specifically written it kind of as a fraction. So the pounds are in the numerator, inches are in the denominator. And I want to ultimately get this to newtons per meter. So one of the things I'm going to do is just make sure, for example, that lbf is here in the denominator. I'm going to have 1 lbf. I'm going to try to find out how many newtons that is. I will go to a unit. I'll give you a unit conversion sheet for the exam. But I'm going to specifically go over here and say 1 lbf to newton. And apparently, according to Google, the answer to that question is 4.45. And so, because this is a fraction, the LBF would now cancel with the LBF down here. So if I took 5 times 4.45, I'd have newtons per inch, which gets me halfway to SIU, or SI, I'm already at SIUE, to SI units, but I want to get to meters. And so the next thing, I would need to have inches in my numerator to cancel with inches over here in the denominator. And so the question is, 1 inch is how many meters? And again, I would look that up on my unit conversion sheet. I'm still going to go to Google for the time being, and apparently this is 0.25 254 meters. And again, the inches in the numerator over here cancels with the inches in the denominator over here, and so the final answer is going to be 5 times 4.45 newtons divided by 0.025 meters. So let's multiply that out and get a final answer. And that apparently works out to 876 newtons per meter. So one of the things we might ask ourselves is, man, that seems like a really big number, especially we started off at 5 pounds per inch. Does that make intuitive sense? And I think that's always a good question to ask whenever you do any calculation. And like I said, we'd be in the neighborhood of 20, maybe 22 newtons per inch, because a newton is apparently a good deal smaller than, it's like a quarter of a pound. And the trick is, think about how many inches are in a meter. It's close to 40. So we took that 20 to 22-ish number and then multiplied by something that's 39.5-ish when you take 1 over that. And so we ended up with something that is pretty big. Because if I took this spring and compressed it an entire meter, that's just a lot more compression than 1 inch, almost 40 times as much compression. So that does make sense. So always have units in the numerator canceling with units in the denominator and get to my final unit, and that's really all there is to it. Thanks.